Mikayla Glick, and she'll be talking about the effects of resmethrin and methoprene on the salt-marsh wolf spider Pardosa littoralis. I see, yeah, the slides look great. So yeah, you can start whenever you want. Thank you.
Good afternoon, everyone. I'm Mikayla Glick. I'm from Adelphi University, and I research the effects of resmethrin and methoprene on Pardosa littoralis prey capture. So Pardosa littoralis is a wolf spider species. It thrives in salt marshes here on Long Island. They don't burrow like other wolf spiders. They're opportunistic hunters, and they have a really huge impact on salt marsh communities. They can eat up to 70 plant hoppers per day. With such a high impact, they're actually really, really important for the ecosystem. And salt marshes are coastal ecosystems that experience regular flooding. They filter water. They provide really abundant and clean nursing grounds for tons of fish, mollusks, and arthropods. They also benefit humans. They act like sponges. They sequester greenhouse gas emissions, which slows the effects of climate change. They store as much carbon as the atmosphere does. And as well as they absorb wave energy, they protect coastal communities from flood damages from Hurricane Sandy. Wetlands alone have reduced damage costs by over $600 million. But marshes are still degraded by anthropogenic forces. As the oceans warm, flooding becomes more frequent and it becomes intolerable by salt marsh communities. Drainage ditches were made in an effort to control mosquito populations. However, they didn't work and they just caused severe habitat fragmentation. Not only that, but pesticides are also sprayed frequently in an effort to control mosquito populations. Pesticides get approved through acute toxicity tests. They only focus on the lethality and they really overlook the sublethal effects on non-target organisms who inevitably come into contact with these pesticides, like Pardosa. There have been many studies done on the sublethal effects of pesticides on spiders. Applying pesticides in non-lethal doses has been shown to reduce spiders' jumping ability, movement speed. It causes them to lose water faster, and it also reduces the activity of certain enzymes like carboxyl esterase and acetylcholinesterase. It reduces the number of egg sacs that those spiders produce, and the offspring that come from those egg sacs also have reduced enzymatic activity. So it just really shows how important it is to consider sublethality during pesticide approval. So the pesticides that are most frequently sprayed on Long Island are resmethrin and methoprene. Resmethrin is a pyrethroid pesticide. It disrupts sodium channels. It paralyzes most arthropods that come into contact with it. Resmethrin degrades really quickly in sunlight. However, it binds to sediments in soil where it could take weeks to degrade. Methoprene, on the other hand, is a juvenile hormone mimic. It's mainly used for mosquito control. It inhibits insect growth past the larval stage by suppressing adult differentiation. They'll still molt and grow, but they never develop any adult features. Methoprene can remain in salt marshes for 2 weeks after application. They degrade about only 80% in 13 days. So we hypothesized that exposing Pardosa littoralis to resmethrin and methoprene in concentrations that mimic those found in salt marshes will affect prey capture. We predicted that both pesticides would reduce prey capture success and increase prey capture time. We collected them from 2 sites on Long Island. This is just to orient you guys. So pretty local. And Cow Meadow Beach is up here. Lido Beach is here. We ended up collecting 71 viable organisms from Cow Meadow and 76 from Lido Beach for a total of 147. We had between 33 and 39 individuals per treatment group. We had 4 treatments. We used methoprene and resmethrin, which were diluted to concentrations that have been found in salt marsh soil. We used acetone to dilute them, so that was our control. And we had a mixture of both resmethrin and methoprene. So we measured the cephalothorax width and mass of each spider. Then we knocked them out with carbon dioxide. to apply 1 microliter of their designated treatment to their dorsal opisthosomas. They acclimated for 10 minutes in a vial before a fly was released into the arena, and the trial was recorded for either 20 minutes or until the spider actually successfully caught the fly. This is an example of a trial using one of our shorter ones. So we can see the vial was lifted, the spider went and caught the fly that was added previously. I'll play that one more time. I think it lags over the stream, but you get the idea. Okay. So we analyzed our response variables were the probability of predation and the time to predation. Our predictors were the treatment, the cephalothorax width, the body condition, which was just a ratio of the cephalothorax width and mass, as well as all interaction terms and the source population, although those were insignificant, so we excluded them. So this graph here shows treatment versus prey capture success. We can see that the control and the methoprene and the mixture actually had pretty high probability of prey capture, between 74 and 85%, whereas resmethrin had a significant reduced probability of capturing prey, down to 19%. It's really interesting that the mixture of methoprene and resmethrin actually ameliorated the effects of resmethrin. However, I'm going to get into that more towards the end of my presentation. So when looking at cephalothorax width and prey capture success, we can see that larger spiders were more probable to catch prey. This makes sense, as larger spiders, smaller flies are more manageable for larger spiders, and as well as they have to stick around to cover. With treatment and prey capture time, before I go into this, I want to say that the power of the analysis was reduced because only 7 spiders that were treated with resmethrin were able to predate. But we can see that the time to capture prey was consistent throughout the control, methoprene, and mixture groups, taking about 4 minutes to catch the fly, and the resmethrin group was slightly higher at around 5 minutes. So when looking at body condition and prey capture time, spiders that were in better condition took longer to capture prey on average, just because they have less incentive to eat if they're in better condition. If they're in worse condition, they're hungrier. To summarize, we found that methoprene did not hinder the ability to capture prey, and we confirmed that resmethrin does severely hinder prey capture ability. But interestingly, the mixture of both pesticides mitigates the effects of resmethrin. It raises the probability of prey capture by almost 60%, which is a new discovery. Studies on the interactive effects of pesticides, especially within biological systems, is really, really scarce. However, we were able to speculate on a few reasons. It might be possible that methoprene is competing with resmethrin's binding site on sodium channels, and that it doesn't have a detrimental effect. It could be that it opens inhibitory channels or GABA chloride channels that will counteract the effects of resmethrin. They could also react to form a completely new compound. We don't really know. We're hoping to look into this further, and our next steps are just to finalize the analysis. We have to do the frame-by-frame movement of both the spider and the fly to see whether each of those affects anything. And then we'll also test this for repeatability in a follow-up study. I'd like to thank Dr. Fulmer for guiding me through everything and really helping me, giving me the opportunity to do this research. Keith helped me a ton with my trials. Lawrence helped me with organizing my data. Adelphi for giving me a place to do this and the opportunity, and the American Arachnological Society for letting me present it to you today.
Great. Thanks, Mikayla. Great talk. Yeah, questions and there's one that came here from Sarah in the chat. Is there a reason you only use the control with acetone and not both with and without acetone? Also, what is the mechanism of action of resmethrin versus methoprene?
We used acetone because it was our solvent, so we didn't want it to like have an effect, like to affect the spider in a way that we didn't catch. So we just used our solvent as our control. And what was the second question?
What is the mechanism of action of resmethrin versus methoprene? I guess in the organism, like of the spiders.
Oh, so methoprene is a juvenile hormone mimic for mosquitoes, but it has been shown to have an effect on other arthropods like lobsters and shrimp. So we just wanted to see if that would have an effect on spiders. Resmethrin is known to permanently open sodium channels, which paralyzes arthropods.
And I have a question: how often they are applied together? Because you show that when they're put together, it doesn't have a larger effect as when it's only with methoprene.
They're applied on the same day often, but not at the same location often. I'm not quite sure what the boundaries are, or if there's like an in-between where they would be interacting, but
I see.
Look into that further.
Okay. And there's one last question here. Do spiders ever ingest methoprene?
Maybe. It's difficult with organisms that you catch in the wild because they're probably have been exposed before and you just don't know it.
Right, right.
Yeah.
And one from Luis Garcia. Do you have an idea about what is the impact of these wolf spiders on mosquitoes populations?
I haven't seen an article specifically on mosquitoes, although they do eat a lot. They really do. So I'm sure it's pretty high, and they must eat the larvae as well.
So it would by themselves be a source of control of the mosquitoes, right?
Yeah.
And one here from Nick, what effects would you expect for higher concentrations?
Higher concentrations would probably be more deadly. Even resmethrin in this low concentration was paralyzing the spiders. So not sure about methoprene though, as it didn't really have an effect.
Very cool. Okay, so I think no more questions are coming. So thanks again for the nice presentation and for the discussion. And now we're going to the next.